If we now consider the equation y prime equals y times 1 minus y, this equation can be solved in one of two ways. We can simply separate variables. We get dy over dt equals this function, which is purely a function of y. So we're going to get dy divided by y times 1 minus y equals dt, so that that's separable. And it turns out, in fact, that that's a logistic equation with limiting value L equals 1 and growth rate K equals 1. So that's a very easy equation to solve using the same techniques in integration that we used in the logistic equation, and is in fact an instance of the logistic equation, again, for which the limiting value of the variable of the population y is 1. Okay, it's also a Bernoulli equation. If we expand this, we see that this is of the form y prime first equals y minus y squared, so it's y prime minus y equals y squared. That's a Bernoulli equation of the form, let's use a different color here, of the form y prime plus p of t y equals q of t y to the n, and the values here are simply p of t is -1, q of t equals 1, n equals 2. And we could use the techniques that we apply to the Bernoulli equation in order to get a solution. So that this equation can be seen as an instance both of the logistic equation and the Bernoulli equation. I'm not going to work out the details. We've gone through a lot of details on logistic and Bernoulli equations, and you should be able to apply those details with the information we've seen here. L equals 1, K equals 1, P of t, Q of t, and n values.